Hi guys, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing stacks topic and following the third pattern, which is stack simulation and undo operation. Today we'll do the last question, which is minimum string length after removing substrings. And trust me, if you have solved these two above questions earlier, definitely you can solve this question on your own, and I can bet you that. So let's read the problem statement. So the question is very simple. If you will read, you have to delete A, B or CD from string. Okay. So how you can delete? If you are standing at B, then the previous character, if it's A, then AB you can delete. Similarly, if you are standing at D and if your previous character is C, then definitely you can delete it. Isn't it same with the previous one where you were deleting the duplicates one or the lower and uppercase? Yes, it's same. But what's the constraint? Constraint here also, it's very small, 100, 10 power 2. So even if you are going to write the brute force code, which is 10 power 5, it will get submitted, because you know, if you're following our playlist, till 10 power 8 or sometimes 5 into 10 power 8 also, the code will be slow, but it will get submitted. If only if the logic in the code is simple. If it's tough, if it's complex, even sometimes at 10 power 7 also you can face the TLE error. But in most of the lead code cases now, we will see the TLE only after 10 power 8. Until or unless recursion comes, and that we'll see it later. Okay, so the question is very simple. We will be at A, we don't have to delete anything. We will be at B, we will check the previous one. Now we can delete both. Similarly, we will be at F, correct? No problem. C, no problem. A, no problem. C, no problem. Now we are at D and the previous one is C. This we have to delete. Again, this current character B matched with the previous character A. Again, this will also be deleted. So don't you think if you are going to run with a simple for loop, correct? We will be at B. Again, you have to go back to check and to delete. Again, the previous one to go back to check and to delete. Yes, something like that. But how can you think of, like, can we optimize it? Have you solved this type of thing before, where you have to go back and check the previous top element? Yes, stack data structure. Very good. So what we'll do, the idea is very simple. We'll start iterating our ith index from 0th index, okay? And if the stack is empty, definitely we have no condition to delete anything. So we'll simply put this A in the stack, correct? Now we'll move to this second character B. We are at B, and the previous character at stack is A. Definitely we can delete. Means A we can pop from stack, and B we will not include it in the stack. So anyhow A and B both are excluded, right? Yes. So we will delete and we will not push B in our stack. We'll move to F. F we will add. C we will add. A we will add. Reason I'll tell you why. You know that because there is no sum popping conditions yet. So we'll move to next, which is C. We will add. Now we will be at D and we'll see that the previous character is C and the current is D, which we have to delete. So hence we will pop C from here and we will not add D, means both are excluded, correct? So we will pop C and we will move to B, correct? Now the current character is B and the previous one is A, correct? Previous one is A. So current is B, previous is A, definitely we can pop and we will not add this. So in just O of n iteration, we have solved this question. Means time complexity O of n, because only one iteration we used. Space complexity also O of n, because for stack we used, right? And now to give our answers C and F, we have to, like, the expectation is string, right? So you have to convert this into string as well. Yes. But so time and space complexity both are n, definitely it will be optimized. Can we further optimize it? Yes, we can. Instead of using stack, if we use a StringBuilder here, as we have already talked about the reason in the previous video, the internal implementation of stack is synchronized and applies locks over every function calls like push or pop, that is time consuming. But in StringBuilder, it's simple array, simple add and delete function won't take much time if we are deleting from the top, correct? So in this case, what we'll do now, instead of adding, like instead of using stack, yes, these are the repetition only because all of these we have already discussed in our previous two lectures, okay? So we'll take a StringBuilder. In the StringBuilder, we will add A, correct? And now currently we are at B, starting from B. So now what we'll check, in the StringBuilder we have A and the current element is B. So definitely we can delete B A and will not add B. Now next time F we will add, C we will add, A we will add, C we will add. And the moment we will be at D. Why I directly jumped? Because till now, like in between, there are no such, you know, popping conditions, correct? So now we are at B, the top element is C, definitely we want to delete, and this D we will not add, we will move to B. Now again we will move to this B, and the current element is A, so we will pop this, correct? And B we will not include, and we'll move out of index. So at the end, this is the string builder, we will convert into string, and this we will return. Trust me, this will be faster compared to the stack. Anyhow, the time complexity is going to be the same, but the only difference is because of the internal implementation, string builder is comparatively faster than stack. So definitely this code will also be simple, right? So I have already written the code for you. So let's see. First we will make the string builder, and then we will run the for each loop to read every character from the S, correct? Then to delete anything from the string builder, first we need to check if the length is positive or not. So first we'll calculate the length, and if we'll check if the length is positive, then only we will check, you know, the condition to pop. And for that, first we'll read the last character, and if the last character is A and the current is B, means popping condition, or else the last character is C and the current is D, then again the popping condition. So what we'll do, we will delete and we will continue, means we will not add that character in the string builder, and we will only add the character in the string builder if this inner if case will not run, means the continue will not run, correct? And at the end, because the question expect to return the length of that you know, string builder instead of string, so we will not convert into string as we were converting in the previous question. So we'll simply calculate the length, and that we will return. So now let's run the code, and as the constraint is very simple, right, only 100, so when we'll submit this, definitely it will be faster. Again saying, we have used this string builder instead of stack. Only in Java we have string builder, correct? In Python we don't have such, so we can simply go with stack. And in the interview also, if you are going to do with stack, it's okay, but if the interviewer forces you to, you know, still optimize it further, then string builder is something they are expecting, correct? And here is the C++ code with the same logic, okay? I hope I showed you the Python code as well. So if you understood the logic, then definitely you can go in the sheet and we can mark the last question as done. And I hope you all would have understood. If yes, do like the video, and please do let me know in the comment section. And if you guys are new to this channel, we are following the sheet, the link will be there in the description. And that's it for this video. Let's meet in another video with some more interesting questions and topics. So then keep learning, take care of yourself and your family.